So we are doing the Taylor series. And McLaurin series. So then, any doubt with that? Taylor series and McLaurin series? Then we have curvature, I think. Curvature or concavity and convexity. Any idea about concavity and convexity? Anyone knows anything?
Derivative positive, it is upward concavity. Derivative is negative, up down concave.
So derivative negative is concave upward. What did you say?
No, ma'am, down.
Concave
Ma'am,
down.
actually double derivative or double derivative negative.
Double derivative negative.
Double derivative.
So what
Double
happens?
derivative negative is concave downwards, and double derivative is positive means concave upwards.
Okay, double derivative is negative means the slope is decreasing, right? And
Slope is decreasing.
so that will be concave downward.
Down.
Downwards.
Downward. Okay, and if you are saying double derivative is positive, that means slope is
Slope
increasing.
is increasing and it is concave upwards.
Okay. Okay. Let's see. So we will discuss. So if you know, we will discuss a little bit. Okay. Then we will move on. Where is the curvature chapter? So you got the book chapter?
Yes, ma'am.
Okay. So here in this module, and you do the exercises. Okay, what we have done for the Taylor series and
Yes,
the
ma'am.
previous part also. Practice the exercises. I also got the book, but where is that? Concavity and what? How you relate concave and convex things? Like if you say the curve is convex, like concave downwards, concave upwards. So which one is the convex function here?
Ma'am,
Concave downwards.
if the curve is lying below all the chords which are formed by joining any 2 points on the curve, then it is concave upwards, otherwise concave downwards.
And actually we use the term convex function. Okay, concave upward, concave downward we say. But which one from this? Which one is the convex function?
And the concave downwards.
Concave downward means it's what you're saying, like inverted type.
Convex.
Concave.
Ma'am,
Double
it
derivative.
will be the vice versa, no? Which is concave downwards, it will be convex upwards like that.
In with the convex we don't have this term. Okay, convex upward, convex downward we don't have. We have only the
Yes, ma'am.
convex.
We have only used concave upwards and downwards.
So you are saying concave downward means negative. The second derivative is negative. That's what you're saying.
Yes, ma'am.
It's the concave upward or downward.
No, ma'am, downward.
Downward. Okay. Concave downward.
Concave downward means bowl shape, na ma'am. So maxima
The bowl will
double
be
derivative
downward
negative.
first. It concave will be negative. Slope will decrease.
No.
We can't tell about slope, na ma'am.
Ma'am, with respect to fx, if x-axis we are considering, then concave would be less than negative. The slope would be
Then
it will
slope
be
will be negative first, then
negative
Okay,
with
okay.
respect to
Let me
x-axis.
draw
With
and you.
respect to y-axis, it will be positive for concave.
Okay, let me draw, then you will tell me. So we will talk about the concavity and convexity. So you have coined two terms, that is concave upward and concave downward. Okay. So we will consider the concave upward first. So this is the initial. So here the condition. Think we fx has continuous first and second order derivatives. In the interval a. So this is the initial condition. Then we define the concavity or convexity of a curve. Now if you say concave upward, so you are saying concave upward means we have the positive second derivative. That means our slope is increasing. So we say concave upward. Okay, the curve is concave upward if and only if the first order derivative is increasing function in the interval AB, or the f double dash x is positive. So the other way you can say, as x increases, the tangent at the point x of x turns in the anti-clockwise direction. Okay. So in the book actually it's mentioned, that means second derivative positive. Such a function is called convex function. The concave upward function is called the convex function. Are you getting my point?
Yes, ma'am.
Yes, ma'am.
Like convex means it's the concave upward, that is the convex function, not the downward. Okay. If your tangent is turning anti-clockwise direction, it will give you a convex function. So concave upward means a curve so in the interval is concave upward if and only if f dash x is an increasing function. Okay, so it will look like this one. So here the tangent turns like this one in an anti-clockwise direction. Okay. So here f dash is increasing, so you can also be in terms of second order derivative, we can say also f double dash x positive on a on the interval. So such a function is called the convex function. So fx is called a convex function. Okay. You remember any other properties for convex function? Yes. Who is on mute? Prayas. Prayas, you're on mute. Mute yourself. Okay. So here, what I'm saying is, so fx is convex function. Simply, if you can able to see that f double dash x is positive, that is one of the way. So here, this is a, this is b, this is concave upward. Function, also known as convex function. In general, we use the term convex function. Okay, we don't use this concave one. Okay, though we say this the opposite is concave. Okay, but normally we used to say whether a function is convex or not. Okay. We also say if you have you can say if it is concave downward, it's a concave function. But in a more general manner, if you go for the studies, you will see in the optimization you will be using the convex function, whether the function is a convex or not. So if you have a concave function given, what you do, you simply add a minus sign and make it convex and use the properties of convex function. Okay, next we will see the concave downward. So just the opposite of concave downward, if and only if f dash x is a decreasing function. Okay, like you did here. Okay, so f of x is concave downward if and only if f dash x is decreasing in the interval ab. Okay, or in other way you can say f double dash x is less than 0 in the interval ab. Okay. Okay, and here this fx is called concave function. Okay. So just know that, but if you go higher, we don't use this concave part. We only use either it's a convex or not concave, convex. Okay. And what actually we do for the concave functions, we simply multiply the negative sign there and we make it convex, and we do whatever we want to do there. So for the concave downward, we are having this. Okay. And here this is your A, this B, and here you can see your tangent is turning clockwise. Okay. So this is concave downward curve. Okay. Also concave function. So now it's clear what is a concave convex function, what is concave downward, concave upward. So when a function is concave upward, it's a convex function. Now we will come to the point of inflection. Point of inflection. So what do you know about point of inflection?
The point where a function changes its concavity
A
or
point
nature.
a point where a function changes its concavity and where double derivative of a function is zero, plus that point should not yield either maxima or minima.
Okay, so the point of is inflection where double derivative is zero. That's the condition you said.
No, ma'am, this is not the sufficient condition.
Okay,
There is
we need a few more conditions. One is double derivative is zero, and it
yes, ma'am.
changes from concavity to like concave downward to concave upward, or the other way, on concave upward to concave downward. Okay, that means the tangent changes its sign. Okay, and uh, and the last one is you said there is no maximum and minimum.
At that point, yes, ma'am.
Okay, only these three conditions enough.
So far I know, ma'am, yes.
Okay, any other condition? I think these three enough, right? So if you have any point is the point of inflection of a curve, then at that point second order derivative vanishes. Okay. So here point of inflection. So the point where the curve changes its concavity from concave upward to concave downward, or the other way, that means concave downward to concave upward, is called a point of inflection. This is the definition. Okay. And we are getting zero because concave upward means we have the positive second order derivative, concave downward means we have negative second order derivative. So the point where it changes, it has to be zero. So from this definition only we are getting that second order derivative is zero. So only the first part is enough, if you say, because from the first part only we are getting this second order derivative is zero. So here, what happens to the tangent line at the point of inflection? Harsh will say, Harsh Mishra. What happens, how tangent line behaves at the point of inflection? Harsh, Harsh Mishra, where you are?
Yes, ma'am.
So what happens at the point of inflection? What the tangent line does there? How it look like?
Ma'am, I think it becomes parallel to the x-axis.
Parallel to x-axis. If tangent is parallel to x-axis, what happens to the slope?
Oh,
Slope
sorry.
becomes zero. Here we are getting the second order derivative zero. Anything else? See, I said
Ma'am, the tangent will cut the curve.
Vertical tangent.
vertical tangent. Tangent will cut the curve. Okay. Because concave. You see, if you are going concave downward to concave upward, suppose at this point of inflection, so concave downward means our tangent is anti-clockwise. Okay. Now, if you go for the concave upward, there will be the tangent will be clockwise. So at the point of inflection, it has to cut the curve. Okay. So, and one another point you said about the maximum and minimum.
Ma'am, have you written anything after point of inflection heading?
No.
Yes, ma'am.
suppose, let's say, I will say you have this one, and our curve is like this one, okay, and this is your point of inflection. Got it? With the tangent, it's going on, it is going this way. Okay, so this is the point of inflection. So if you look at the tangent, what happens here? It will be something like this one. Got it? Not the vertical tangent, but it will definitely cross. Okay, cross this curve. Okay, the tangent will be like this. So is it possible
Ma'am,
if the
it
second
will
order
get cover at only one point, na?
at the point of inflection?
Yes, ma'am.
So we will write those things. Okay. Now what I want to know is it if the
Yeah,
second order
ma'am,
derivative? Yes.
if the graph will be like of sine x, so what will be the point of inflection?
You say.
I have no idea. That's why I'm asking him.
You say what are the points? Okay. Let's do the
If the
method.
graph will be like of sine x,
Draw it. Put the sin x.
Pi by 2, no?
Okay.
0 pi
Many points of
Pi by
N pi,
2,
inflection.
I
n pi.
think, and pi, yes, and pi.
n pi. Yes, ma'am.
So the points here, this is the point where it changes, right? This is the concave downward, and this is the concave upward. Okay, the points, these are the points where the curve is changing from concave uh, upward to concave downward. Okay, got it? So these are the points where you will have the points of inflection. And what happens to the second order derivative? Is it zero? It's becoming zero. Okay,
Yes, ma'am.
and you see these are not the points of maximum or minimum also. Got it? So the first definition you should look at. Now what I want to know is if the second order derivative, is it possible it's if it does not exist and still the point is the point of inflection?
Yes, ma'am, it is possible.
Any example you can give?
Ma'am, like we can have
See,
a sharp corner graph where you can have a sharp corner, so there is second derivative will not exist, but it is a point of inflection.
sharp corner, let's say this one. We will make it this way.
And
Non-differentiable
not
point.
when we can make it curved, like one from one end it is concave upward, and from then it is concave downward.
Okay, let me draw this one. Is it this way you're saying? Let's say this way. Is it like this? Here,
Take off mod sin x, na, ma'am?
mod sin x. Okay, how mod sin x? So here, mod sin x.
Yes, ma'am.
Is it like this? So these are the
Yes, ma'am.
points.
Yes, ma'am.
Again, points of inflection. Okay. But here, what happens to the first derivative? Okay, this is decreasing, this is increasing. Okay, the definition is true. Got it?
Ma'am,
So
but these are the minimal. Na?
these are the minimal. So whether it's point of no, what I'm saying is we will look at the definition first. Okay, while these are the latter part comes. Okay, so here f dash takes. This is again you will say concave downward. Each curve is concave downward, isn't it? So whether it's a point of inflection.
No, ma'am.
Ma'am, we can have like one from one end it is concave upward, then it is a sharp point, then it is going concave downward. So that it is a point of inflection, but derivative doesn't exist.
Can we say like that? Any other idea, or what he is saying is right? Like you see, if you look at here, the slope is decreasing in the first part. what he's saying, if you come here, the tangent, whether you go this side, it is this side, okay? And here, if you say tangent go this way, isn't it? So it's concave downward and it is concave upward. So at this point, it is changing from concave downward to concave upward. So here is it a point of inflection? Because at this point, you see f double dash x, whether it exists or not. Your f is here.
Ma'am,
You see
can y
about
is equal
sin
to,
x. Okay.
excuse me, ma'am.
Yes.
Ma'am, can y is equals to 1 upon x to the x cube can be an example of such point where
One
f
upon.
double s is not defined yet that point is an inflection point.
So the second derivative, what will be the second derivative? Here 1 by x cube. So if you go for 1 by x cube, what is f dash x? Minus 3 or 4?
Ma'am, for 1 upon x cube, it is a discontinuous graph, so we can't say it is point of inflection.
At the origin. At the origin, right?
Yes, ma'am.
Are you talking about 0?
At
So
0.
it's 0. So at 0, it is discontinuous. Otherwise, it's continuous. So what we want to know, how it will behave. This is 1. So within 1, it will increase.
Now it will decrease, ma'am.
How
From
it will
top to
be?
bottom, it will
Decrease.
decrease.
Is
Yes,
it
ma'am.
like
Like that.
this?
Yes, ma'am.
Hello, ma'am. Ma'am,
Okay.
we can take
Yes.
mod ln x.
See, it doesn't matter. What I'm saying is if the second derivative is 0 from the definition we are getting, but is it possible that if it is, it exists or it does not exist? So here,
Yeah, I
here
have a
at,
doubt.
yes, what is your doubt?
If f dash x does not exist, can we say it is a point of inflection?
F dash x.
In the previous example, the f dash x is not existing na, here.
Yes, ma'am. So there we can't. Can we find f double dash of x? It is
But at the
non-differentiable,
point,
no?
with at the point of inflection, what I'm saying is, what about the sign here? This f dash x is decreasing. So f double dash x, if you see, here it is negative, and the neighborhood. If suppose this is a, so at a minus it must be negative, and f double dash x is positive at a plus h. Okay, so it changes sign at a, but at the point a doesn't exist. Okay, so it is a point of inflection or not?
No, ma'am, it can't be a point of inflection.
Ma'am,
Right?
it is because for point of inflection, there is no role of f dash x or f double dash x. If it is changing
It's
concavity or convexity, then it is point of inflection by definition.
from the definition, what I'm saying. So here also the same thing happens. Okay, you tell me about this 1 by x cube. This will be, I think, 0. This 1 by 2. something like that. 1 by x cube if you draw. So we have at 1 what happens? We
Ma'am,
have
it
the
will be
value 1.
decreasing from 0 to infinity. It will be totally decreasing. 0 highest point, maximum value, then it will decrease.
I got it, but within 0 to 1 what happens?
Decreasing.
Decreasing.
1 by 2,
Its graph is just like 1 by x.
but closer to origin, much closer to it. Just the other way. So at this point what happens? 0 is a point of inflection or not?
Yeah, at 0, function is not continuous.
At 0 it's not continuous. Okay. So I'm not bothered about that. We will not say about that. But this is here. Okay, in this side it is. Let's say it's decreasing kind of thing. And here in the negative side.
In the negative side, it
So
is
at 0,
minus 0,
-0.
minus
So what I'm
infinity.
saying at the point, what happens?
Ma'am, it is point of inflection because we see left and right side means if it is changing slope, then it will be the point of inflection. No?
Yes, ma'am, it should be the point of inflection. Concavity is changing.
So
Uh,
at 0, we have point of inflection.
yes, ma'am. Because we don't have any
Okay.
role of that
So the
point,
same thing will
we see
happen here
nearby.
in sin x also. The only yeah, and there is one thing you can check here, like x power 5 if x is positive, however small it must be, it is positive, the second derivative. And if you go for x negative values, again very small, it will be a negative value, right? They like 0 plus h, we have f double dash x positive and 0 minus h is a very small value, and this that means what I'm saying is that in the delta neighborhood. So here these things are happening. Okay, so this side it's changing the value, so it will be a point of inflection. Okay, so similarly let's consider another function, that is fx equals to x power 4. So what happens here? You see f dash x 4x cube f double dash x 12x squared. So what again at x equals to 0 what happens? What you can say, is it a point of inflection? Here also it's a point of inflection. Okay. So what I want to say is that even if the second order derivative does not exist at that point, but the second order derivative are opposite signs. Okay, for a in the neighborhood. Okay, in one side it's positive, in one side it's negative, then we can say it's a point of inflection.
And then what we concluded from this example f of x equal to x to the power 4.
That you do. X power 4 I didn't solve, I only did for 1 by x cube. So you look at the sign, since we are getting 0, the first derivative also we are getting 0, second derivative also we
Yes.
are getting 0. Okay, so now what we have to do, we have to look at the sign. Either you look at the second derivative sign, or you look at the whether f dash is increasing or decreasing in the neighborhood. One side it should increase, one side it should decrease. So what is it, a point of inflection?
Yes, ma'am, it is.
Does not exist, we will say. Exists, but n pi, the first one. But x equals to n pi will be the point of inflection. Okay, because this happens. So this one is for the 1 by x cube. So what happens to the f double dash x here?
Excuse me, ma'am.
Yes, at x 0 minus h. Okay, I'm 0 minus h writing so that you will understand that it's the like in the left side. Okay, what happens? Yeah, what are you asking?
Ma'am, in the graph of f of x equal to mod sin x, the concavity is not changing. So how can we say that it is a point of inflection?
Concavity, if you say it's concave, but it is going now from concave downward to concave upward. It is moving.
Ma'am, in the graph of f of x equal to mod sin x.
This part, okay. If you look here, so if you this one is going this way, or if you look at this one, tangent, and here if you look at this one, the tangent. Okay, so this one, this is concave downward,
Both are going clockwise.
both were clockwise, but if you go this one, this is going down.
And the other one will also go down eventually.
Ma'am, the direction of the tangent is not changing, na?
But the sign of slope changes abruptly,
Okay.
na, ma'am? From negative to positive.
Ma'am, it is point of minimum.
Yes, ma'am, it is minima,
Point
not
of minimum also. That is also point of minimum. That is also true. Okay, you find for x4. I'm coming to this one.
Ma'am, can we also conclude that continuity is not
At the
necessary?
point of inflection.
Okay.
Okay, you look at x power 4. Like we did for 1 by x cube there. We are saying that it's the point of inflection.
ma'am, no point of inflection.
No point of inflection. At
Yes,
0,
ma'am.
what
No
happens? At
point.
0, what happens?
Ma'am, it is
Ma'am,
the
it is
point of minimum.
minima.
At 0 is not a point of inflection here. What
Oh, ma'am, it
happens?
doesn't have any point of inflection.
Okay.
Zero is
Now
a
what
point
happens?
of minimum, ma'am.
0 is a point
F
of
triple
minimum.
dash.
Okay, so what is the
F
sign
triple dash
here?
is not equal to 0.
So if you go for
0.
minus h, here what happens? F double dash x, it's positive, right? At minus h. And if you go for the plus h, then also it's positive. So sign is not changing, so 0 is not the point of inflection. So no point of inflection. Okay, only 0 was a point where we expect, but there are no point of inflection. That's right. Okay. Okay, now we will do some problems. Okay. So you have some idea now. So find the intervals in which the following curves are concave upward or concave downward. minus 6x square plus 12x plus 12.
Ma'am, that is
Minus
minus 6x square.
yes, this is minus 6x square. This is e power minus x square x plus 1 power 1 by 3. Also find the points of inflection.
Ma'am, could you please show the third question?
Actually, I shared it with someone. Are you able to see it? The OneNote.
Yes, converted that to a PDF and shared it
PDF? You got the PDF? What I said?
in the.
You didn't get the entire OneNote? No, what I want to know is you should be able to see the today's class also.
Ma'am,
You got that?
yes, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am. Yes, ma'am. I shared the complete OneNote to the complete class, and then after that, I converted the complete OneNote into a PDF and then shared it to the class again itself.
And the class, are you able to see that OneNote link? Anyone who has checked?
Yes, ma'am.
You are able to see that OneNote pages, what I'm showing. And you just check whether you're able to see today's class or not. I think the link I shared, so you should
Okay,
be
ma'am.
able to. Okay. Next class, you inform me.
Okay, ma'am.
Done.
So what is the point of inflection for the first one?
-1 plus minus
minus
root 37/3.
Minus 1 by 3 and 1.
Minus 1 by 3 and minus 1 and 1 by
Minus
Ma'am,
1
when
and
you are
minus
doing
1
that
and
1
1
by
by
3.
3. Yes, ma'am.
okay.
Yes, ma'am.
Minus 1 and 1 by.
Minus 1 and 1 by 3. So here
Ma'am, by
what is
making graph, it is showing no point of inflection.
Ma'am, making graph, it
Yes,
is
ma'am, it is
showing
a
it is
vertical
a minimum.
parabola.
Yes, ma'am, making graph, it is showing no point of inflection.
Yes, ma'am, because minus 1 at least is a minimum.
minus 1 is the minimum?
No, ma'am, minus 1.5. Sorry, 0.5. Minus 0.5 is the minimum.
Ma'am,
Ma'am,
because
minus
in
1 is
f
the
dash
minimum.
x at x equal to minus 1, it's coming 0.
Where if double dash x is 0 at minus 1
Yes, ma'am, at x equals to minus 1 at f dash x comes 0.
and double dash x?
Yeah, also in double dash x, so it comes 0.
And double dash x is 0 at 1 and minus 1 by 3.
Okay, let's see.
But according to graph, we cannot say that at point minus 1 we can have a point of
But how do
inflection.
I know you are drawing the right graph? If your second order derivative is vanishing and graph is becoming concave upward to concave downward, right? While drawing, we only consider very few points. So you check at one minus 1 it
No, ma'am,
vanishes.
we are using internet for graphing.
That doesn't matter. Okay, as I said. So here why this is so fx f dash x. If you see what is f dash x, let's look at the points, right? 12x cube plus 12x square minus 12x plus 12. Okay. Then f double dash x. Okay. So here we have so this is your the second order derivative. So the points where f double dash x, okay, will be 0, where for x equals to 1 by 3 and minus 1. So if you are getting 2 points, we will check whether the graph is changing the direction or not, from like from concave upward to concave downward or not. Okay. So simply you check at the neighborhood the what happens here. Okay. So let's look at 1 by 3. Okay, we have 1 by 3, so we will consider 1 by 3 minus h. What happens to the sign at this point? Okay. So yeah, whether sign is negative or positive, what will be the sign? What you can say about the sign? Suppose you put 1 by 4, what happens? It becomes negative, right? So here it will be negative.
Ma'am, I think you wrote the wrong equation there. Uh, there should be a
Well,
minus in the question, and here you wrote the different things.
if dash x is right,
Ma'am, I think there is difference in sign. The question you wrote starting and now there is difference, I think.
Ma'am, f dash x is right.
let me
Ma'am, in the
check.
question you wrote 3x to the power 4 minus 4x cube, I think.
Minus
Yes, ma'am.
4x
Minus 4x cube is written.
plus 4x
Plus
cube
4.
minus 6x square plus 4x cube.
Ma'am, it
Ma'am,
was
the question is right.
The question is right now.
Yes, ma'am, you wrote right.
Question
You
is
check.
right, but it is coming a minimum.
No, no. If you change, suppose you have changed the sign, accordingly you will be getting. Okay, no issues. You just check what happens. You procedure remains same, and there you have to check also what it, and if you can draw the graph and whether you are not getting from that. Okay, so here it will be less than 0 because you see for 1 by 3 it is becoming 0. For less than 1 by 3 this term becomes negative, so we have the negative. And similarly if you look at here 1 by 3 plus h, little bit more than h, so it will be greater than 1, so it will be a positive one. So you see at 1 by 3 it is changing sign from concave downward to concave upward, it's becoming. So this is 1 by 3 is a point of inflection. Got it? So from this you can say 1 by 3 point of inflection. I just use the definition. Okay, that is concave downward to concave upward. Similarly, you try for minus 1. What happens for minus 1 minus h here? So if here we have minus 1 minus h, again you see minus h will be there. So we have the negative sign here. Minus 1 minus h. So what happens, positive or negative?
And positive.
Will be
Smart.
positive, no? With 3s.
Here also,
Positive.
right? Yes, it's here also. So we will have positive here. Okay, and if you look at here, minus 1 plus h, here I think negative. Negative is coming.
Yes, ma'am.
So if you have doubt, what you will do, a simple small value, instead of minus 1, you can go for minus 0.9 and put it in the equation. And similarly, if you here, you can go for minus 1.1 and put it in the equation, calculate, and that will give you this. Okay. So again, you see concave upward to concave downward. So this 0. I'm sorry, it's minus 1. minus 1 is a point of inflection. Okay, so it's again a point of inflection. So we are getting 2 point of inflection. Any other point where it is changing direction?
Ma'am,
So yeah,
ma'am, f dash x comes at x equals to minus 1 also comes to be 0. So it should be a maxima or minima as well, right?
where?
Ma'am, f dash x, I solved for f dash x. F dash x comes as x plus 1 multiplied by x square plus 1 multiplied by 12. So x plus 1 is also maxima or a minima.
If you put x equals to 1, f dash x becomes 0. No?
X
No,
equals
ma'am.
to minus 1. It becomes 0.
At what point f dash becomes 0? At
Ma'am, at
1.
x equals to minus 1, f dash x becomes 0.
Okay, x equals to minus 1. So
Ma'am, it
x.
is not
Yes.
zero. Ma'am, it is not
No,
zero.
ma'am.
It is
Ma'am, I
24.
think she has written 3x to the power 4 minus 4x cube. That's why she is getting.
Yes, ma'am, I made a mistake. Yes, sir.
It's
Sorry.
not 0. If it's 0, you have to again check. Okay. So our only purpose, we will check whether what happens at the both sides. Okay. If you are getting all kinds of thing, look at the definition. What happens in the right side? What happens in the left side? Okay. The definition. When nothing works, only the definition work. Okay. Next, e power minus x square. Done.
Plus minus 1 by root 2.
Both are points of inflection.
Yes, ma'am.
Okay, should I do it or I can do it? What is the graph? I think here graph will work. Y equals to e power minus x square. Okay, so this graph, kind of normal distribution graph. It's a normal distribution only. Graph will be like this, isn't it? You can
Yes,
do
ma'am.
it also.
Yes,
Just
ma'am.
see, just know, you know, and it's a very known.
Ma'am, what is the answer for this one? Second question.
You said no, 1 by root 2 and minus 1 by root 2. So the
1
points
by
of
root 2.
inflection, see, I think this is the point you see. If you look at here, it will go like this, and here it goes on like this. Okay, but at some point here it is becoming like this. Okay, so this is your point of inflection, minus 1 by root 2, and I think here the same here, 1 by root 2. So
Yes, ma'am.
here it is, and at this point it will go. Okay, the point where it changes. So these are the 2 points. Okay, you have to check. Okay, you find out y dashed, y double dashed, and do it.
Hello, ma'am.
Yes.
Ma'am, in first question, I have a doubt. Is it necessary that when f double dash of x is greater than 0 and at some point and nearby it
Not
f
at
double
some
dash of
point.
x less than 0?
See, not some point. See, if you draw the real line, what happens here? I'm not talking about not some point. Okay, so if you
No, no,
look
ma'am. Here
here,
it's 1 by 3, no?
uh,
So at 1 by 3, left side f double dash is less than 0 and at right side it is positive. So it is necessary that the point will be a point of inflection.
yes, the definition. See, less than 0, greater than 0 means if you make it 1 by 3, what happens here? At this point, we have the concave downward, isn't it? At this 1 by 3, here it is. You see, this is less than 0 at this side, so it is concave downward. What I'm saying, mathematically we are looking at less than 0, And if you see this side and this side, it is concave upward. And what is our definition? It's saying, definition is saying, if the graph changes from concave at the point concave downward to concave upward, that is our point of inflection. Here also, I think this one less than 0, -1 right side, left side is concave upward.
Got it, ma'am. Yes, ma'am.
Got it? So if you draw it like this, it will happen. Okay. So similarly here also you have to do the same process remains same. Okay. Find out f double dash x, then set it 0, and if you are getting any point, then you look. Okay, once you get the point, then you have to check also whether the sign of f dash x is positive, like opposite in the opposite sides of 1 by root 2 and in the opposite sides of -1 by root 2. That you have to check. And since it's a very known function, I am drawing this graph. Okay, here it is going up, and from this one here going a little bit down. So okay, here this one is, what will be this, concave upward.
Concave up.
So here concave up and here concave down. So up it is going, concave up, and this side concave downward. And after this point, again the graph is concave upward. Okay, so here these are the 2 points where it happens, but you have to find it mathematically. Okay, that is easier because drawing graph will not give you the idea every time. Okay, and once and also finding the second derivative will not give you, so you have to find this one. Okay, then the next one you are done. Okay, it's already
No point
Minus
of
1.
inflection.
no point of
-1 is the
inflection.
point of inflection.
-1.
-1, but at
So x
minus,
is equal to -1.
-1, ma'am.
so at that point, what is the value of f double dash x? Not defined.
Yes, ma'am.
Please
Not
show the question
Not
again.
defined.
It's not defined, but still, it's a point of inflection. Okay.
Ma'am, can you show the question again,
One
please?
question.
Fx equals to x plus 1 power 1 by 3. Here. So the graph you're saying here. Okay. So here it will be like at -1, right? -1. So here. Okay. So this
Ma'am,
is.
this will be at -1, not 0.
I'm making it -1. Okay. Let me make it this as origin. What is it? So this is -1. Okay, so by looking at, you can say this side it is concave
Up.
upward. Okay, and this one is concave upward. And here concave downward. Okay, so at the -1 the function is continuous. Okay, unmute. Who is mute? Pratyush. Okay, so here you can see it's concave upward, concave downward, so 0. Sorry, -1. -1 x equals to -1 is a point of inflection of this function. And I think only one point of inflection.
Yes, ma'am.
Yes, ma'am, only 1 point.
So again you find out f double dash x, and it's not 0 at any, you can say it's a finite x. Okay, not defined, f double dash x is not defined at -1 also. but it's the point of inflection. Okay. Okay, we will continue next class also. Okay.
Excuse me, ma'am.
Yes.
Ma'am, what was the conclusion of the f of x equal to mod sin x graph? Was that point of inflection or not?
I feel it's a point of inflection, but you also go through next class again. We will discuss. Okay.
Okay, ma'am.
Ma'am, is continuity a necessary condition for point of inflection?
So, like I have written here, this is your definition. Okay, I have written for the concavity and convexity. So here you should find this f double dash x. Okay, since f double dash x finding will be tough, so you should look at concavity and concave upward and concave downward. The graph changes from the point of inflection is the point where the graph changes from concave downward to concave upward, or the other way, concave upward to concave downward. That is the definition. Okay, just try to use that one and come up with your version.
Ma'am,
We will discuss it next class. Okay. Any
Ma'am,
other?
if a point is not continuous, then it can be a point of inflection, as in case of 1 by x and 1 by
1
x
by
cube.
x, 1 by x cube.
ma'am.
Yes.
In first question at point 1 by 3, we have concluded that at left side, f double dash of x is less, and at right side, it is positive. So there is point of inflection in between.
Here 1 by 3 and minus 1.
Yes, ma'am.
1 by
Now
3
in
is the point of inflection, and
yes, ma'am. Now in mod sin x, to the left side, that is means consider pi means pi point. So left side of it is also same value, and right side also same. So how that can be
positive
a
value.
point of inflection?
So both we are getting positive values, right? Uh, we will
So
see.
that can,
That's why I said no. I can say that you come up with your versions, and next class we will
okay.
discuss. Okay. What you're saying, you will we will discuss a little bit. Then we will start all things. Okay. Okay then. So I'm ending the class. It's already more than 10 minutes. Go and have your lunch. Okay. So I'm ending the class for today.
Thank you, ma'am.
Thank you, ma'am.